Hi everyone, this is lesson 3-3 in geometry, and we are going to be looking at page 162, proving lines parallel. Now the last lesson that we learned in 3-2 was full of situations where we already knew that the lines were parallel, and then we learned things about the angles that were created by parallel lines crossed by a transversal. But again, I want to stress that all of those things, like knowing that corresponding angles were congruent, knowing that alternate interior and alternate exterior angles were congruent, knowing that same side interior angles were congruent, all of those things were based on the fact that we knew or were given that the two lines were parallel. So this lesson takes an opposite approach. This lesson causes us to think through it backwards. So this time what we're going to say is if two lines are crossed by a transversal, notice I didn't say parallel lines, but if two lines are crossed by a transversal and any of those things that I just mentioned before are true, such as corresponding angles are congruent, alternate interior or exterior angles are congruent, or same side interior angles are supplementary. If any of those are true, then it actually proves the two lines crossed by a transversal to be parallel. So if you need me to repeat that, then go back and listen to that again. That's very important in kind of the premise for this lesson. All right, so let's start by looking at that. Remember, we studied our conditionals, our if-then statements, and we studied the converse of the if-then statements and how some of them can be reversed and still be true. Well, these that we're studying today that are simply the converse of what we studied in lesson 3-2 are in fact true. So let's start by looking at the first one, the converse of the corresponding angles postulate. I'm going to put the phone right here so that you can see both, hopefully. If two lines, I'm going to leave out the coplanar part. If two lines, here are my lines, M and N, are crossed by a transversal, notice nobody tells us, or the diagram doesn't tell us, that these are parallel. So we're just going to call them lines. If two lines are crossed by a transversal such that the corresponding angles are congruent, then the two lines are parallel. So we see that, or we're told by the diagram, that angles 1 and 2 are congruent. We can tell that by the matching arcs. And we know from previous experience that those are corresponding angles. Because they are congruent and because they are created by two lines crossed by a transversal, that proves that the two lines are parallel. So, in fact, M is parallel to N, or line M is parallel to line N. So let's look at a couple of examples based on that. Let's look at example 1. Using the converse of the corresponding angles postulate and the given information, use all of that to show that L is parallel to M. Let's look at our diagram. We want to show that line L is parallel to line M. Now, one thing I want you to notice here is that when you're discussing this from the backwards direction like we are today, you can't call it the corresponding angles postulate. You must call it the converse of the corresponding angles postulate, otherwise it wouldn't be correct. The corresponding angles postulate is built on the premise that we already know the two lines to be parallel. When we're dealing with the converse of it, we're showing the two lines to be parallel. So while that may not seem like an important difference, it's a huge difference. All right, let's look at example A. Remember, we want to prove that L is parallel to M. All right, angle 1 is congruent to angle 5. Let's look at our picture. Angle 1 is congruent to angle 5. Well, think for a second about what kinds of angles those are. I'm hoping that you're noticing that they are corresponding angles. They hold the same spot in the two sets of angles that were created by these two lines crossed by a transversal. Because they're corresponding angles, and because the problem tells us that they are congruent, then we use the converse of the corresponding angles postulate to say that line L is parallel to line M. So our reason would be line L is parallel to line M based on the converse of the corresponding angles postulate. You can see that right here. Line L is parallel to line M based on the converse of the corresponding angles postulate. All right, let's look at another one. This one gives us algebraic expressions for the angles. The measure of angle 4 is 2x plus 10. The measure of angle 8 is 3x minus 55. But then they tell us what x is actually equal to in this problem. So all I'm doing is circling that x. And that x plugged back in looks like this. Let's look at it. The measure of angle 4 is 2 times 65 plus 10. Remember, our x was 65. That equals 140. The measure of angle 8 right below it, which came from right here, is 3x minus 55. Plug the 65 in for the x, and our answer is again 140. So what we learned by doing that algebra is that the measure of angle 4 is equal to the measure of angle 8. Let's go back to our diagram. Angle 4 is the same as angle 8. Do you notice that those are corresponding angles? Since they are corresponding angles and since they are congruent, we are using the converse of the corresponding angles postulate to show that these lines, in fact, have to be parallel. So this is not real complicated, especially because of what we've already had experience with. But let's look at one more. We're using the same postulate, doing the same thing. This time they're simply telling us the measure of angle 1 is congruent to the measure or equal to the measure of angle 3. 1 and 3 are corresponding angles. Because they're congruent corresponding angles, that proves lines L and M parallel. And then the same thing would happen in 1b if, let's see, here we were told that x equals 13. I know this seems like a lot of information. It took me a minute the first time to kind of go, what are they telling me and what are they asking me? But they give us the measure of angle 7. We plug 13 in for x. They give us the measure of angle 5. We plug 13 in for x again. And I'm going to do the math on these two really quick in my notebook, which you cannot see. So give me just a second. I'm going to say 13 times 4. That's 52, plus 25 is going to be 77, as long as I didn't make any careless errors. So that one's 77 degrees. Now let's look at the second one, 5x plus 12. So 5 times 13, that's 65, plus 12, again, is going to be 77 degrees. So we know that angles 7 and 5 are congruent. 5 and 7, they both equaled 77 degrees, and because they are congruent and because, as you see, they are corresponding angles, they prove the two lines L and M parallel. All right, let's go to the bottom of the next page. We're not going to do the top of the next page at the moment. We're going to come to the bottom of it, to the theorems again. This is exactly what we were just doing, except for this is the converse of the alternate interior angles theorem, the converse of the alternate exterior angles theorem, and the converse of the same side interior angles theorem. So let's look at these, and I'm going to try to go very quickly. If two lines, actually you look at it over here, if two lines are cut by a transversal and their alternate interior angles are congruent, then that proves the two lines to be parallel. Moving on to the next one, if two lines are crossed by a transversal and the alternate exterior angles are congruent, it also proves the two lines to be parallel. And lastly, if two lines are crossed by a transversal and the same side interior angles are, remember this, not congruent, but supplementary, then that also proves the two lines to be parallel. All right, I'm going to get you to flip your page. Now, of course, you can pause the video and look at those and really try to absorb them if you need to. But let's flip the page and look at example 2 where we're going to apply this. Use the given information and the theorems you have learned to show that line R in this diagram is parallel to line S. All right, the first one tells us angle 2 is congruent to angle 6. Let's go look at the diagram. Angle 2 is congruent to angle 6. Think about what kind of angles those are. They're in between the two lines and they're on opposite sides of the transversal, so they're alternate interior angles. Because the problem tells us that they are congruent and because we know them to be alternate interior, we can use the converse of the alternate interior angles theorem to prove that lines R and S are parallel. Remember what that converse theorem said? It said if two lines are crossed by a transversal and the alternate interior angles are congruent, then the two lines are in fact parallel. All right, and remember, you have to differentiate between simply the alternate interior angles theorem and what we're using today, which is the converse of the theorem. You would have to note the difference carefully or answer a question differently on the test. All right, let's look at letter B. My doggie is crying or barking in her dream, so I'm sorry for the background noise. Okay, here we have the measure of angle 6 is this algebraic expression, 6x plus 18. We have the measure of angle 7 is 9x plus 12, and we're told that for each x equals 10, I went ahead and did the math on this one. 6 times 10 is 60, plus 18 is 78. 9 times 10 is 90, plus 12 is 102. So let's go look at that. The measures of angle 6 and 7. The measure of angle 6 was 78 degrees. This may be very hard for y'all to see. That was 78 degrees. The measure of angle 7 was 102 degrees. 102 plus 78 is 180. These are same side interior angles. They do meet the criteria in that they are supplementary. So we have same side interior angles that are in fact supplementary, which does in fact prove that R and S are parallel lines. All right, I'm checking my time. I think we have time to do a couple more of these. Let's look at, it says use the diagram above. We're looking at the check it out, and we're going to look at the measures of angles 4 and 8. 4 and 8, and we're told that they're congruent in the problem. These are alternate exterior. If they're alternate exterior and they're congruent, then the converse of the alternate exterior angles theorem tells us that R and S would be parallel if those two angles are congruent. All right, we're not going to do this one. It's again doing the same thing that we've done several times now, inputting the value of the variable into the algebraic expressions and comparing those angles, and then using the converse theorems to prove the lines parallel. All right, I do want to look at this one quick proof with you for continued proof practice. So I'm trying to figure out if I can hold my phone and let you see all of this. I think I can by slanting it. All right, so we're just going to run through this quickly. I have to watch the time or my video gets too long to download it or actually upload it to my YouTube page. So let's glance at this as quickly as possible. We are given that L is parallel to M. So in this case, we're starting with 2 parallel lines, but if you'll notice, we have 2 other parallel lines that we don't know are parallel. Then we're told that 1 is congruent to 3. Remember, draw, 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 label, label, label. So it's already drawn or labeled that the 2 lines are parallel, the L and the M lines, and I've labeled that angles 1 and 3 are congruent. Now let's start looking at this proof, and remember it's angled so you can see the whole thing. Our first given tells us that L is parallel to M. We know that. Our next thing that they put in the proof is what they gleaned to be true just from knowing that the 2 lines were parallel. They're going to wait and put the second given in. But right now, they're going to say that angles 1 and 2 are congruent because with lines L and M parallel and crossed by this transversal, this top transversal P, we know that angles 1 and 2 are congruent based on the corresponding angles theorem. So I'm going to go ahead and mark this one congruent to the other 2. And their reason for that was the corresponding angles postulate. We can use postulate and theorem interchangeably, so don't worry about that. I treat them all as basically a rule. All right, from there, we do the second given. Angle 1 is congruent to angle 3 given. Now, what can we do from there to work our way to proving that lines R and P are also parallel? They say that angle 2 is congruent to angle 3. Well, we know that to be true because we already were told that 1 and 3 were congruent. Then because L and M, lines L and M were parallel, we were able to know that 1 and 2 were congruent. Now we see that 2 and 3 are congruent, and we can put that in and call it the transitive property of congruence, or you could have even said substitution there. But now I want you to focus on lines P and R and the fact that these 2 alternate exterior angles are congruent. Because they are, we can use the converse of the alternate exterior postulate or theorem to prove that since these are alternate exterior angles and they're congruent, that these lines R and P are in fact parallel. So we would write that they're parallel, and then we would put that converse reason. And I'm going to have to end there so I finish in time. Hope this is helpful. Your homework is actually a review page that includes some problems from this lesson.